This is my current test setup to evaluate two small Turnigy N2223 brushless motors with one speed control. I have the motors then mounted on about a 5-pound or so piece of lead. I've got that onto a digital scale. It is secured down by some Velcro so it doesn't vibrate around. I can turn on the scale, get the tare weight, reduce it to 0, and then as my props tend to unload, I can read the negative unloading, or therefore the grams or ounces or pounds force as the case may be. Now the data then is going to be sent via an EagleTree V3 recorder into my laptop, and of course for easy viewing I have again my large LCD monitor. I've had a problem in the past with RPM finding out that these brushless motors in the EagleTree calibration with the RPM sensor is a 6-pole motor. So to verify the RPM, I put a piece of special luminous tape per the recommendation of my optical digital tachometer. So I can use this then to get true RPM, in other words, one blade rotation pulse, and then compare that then with my EagleTree and my RPM setting on that. Now this is all going to be controlled by a little servo eliminator circuit, and I'll be powering it by a 3S 5000 milliamp hour 40C litho pack. Now I'm kind of afraid of propellers, so what I've designed is a Lexan shield that will actually go in front of this, and of course if the propellers then decide to go south on me, at least part of my family jewels will be protected. At least that's a game plan anyway. So let's start with some tests then and see how under load conditions two brushless motors with one ESC actually performs compared to a single brushless motor with single ESC. To begin the test, I have my tare weight set at 0. I'll use my little servo controller. Starting the test again as a repeat, my RPMs. End of test. Well, I've gathered and analyzed all the data from the first run, the second run, computed the watts, the RPM, the thrust in grams, the thrust in pound, and the thrust grams per watt of output power. So I'll post this on the net, but now it's test number 2. So I've removed one of the small Turnigy brushless outrunners. To keep things the same, I'm using the same mounting block, but now have moved the single outrunner directly into the center rather than 2 on either side. I have the identical setup, so we'll start with trial number 1. I'll crank up an RPM on my speedo. Probably a good starting RPM. There is our I've tabulated the results from the first test with the 2 motors, 1 ESC. The first one run and the repeat run. I've come up with watts, thrust in grams, thrust in pound, and then a unique parameter called grams thrust per watt of expended energy. I have then removed one of the brushless Turnigy motors. I'm now into the single motor setup. I'm using the identical mounting bracket. I will put on my tare weight down here at 0. We again have the same base weight onto it, and crank up my RPM and get a couple of data points. So here is increasing RPM. And that ends the test. Far lower thrust output on a single motor than dual motors. But let's look at the data now. This is my final test of the series. I have a single motor, single ESC. I've actually changed the motors around, swapped them. Still identical configuration mounted into the center. I have my Eagle tree set up. We have the identical battery, the identical BEC. So what I'll do is I'll turn on my tare weight again. And you can see this nicely zeroes out. I will go to the live mode on my Eagle tree. And there we have it. So what I'll do is start increasing the speed and recording the data. End of test, and we'll compare that to the previous run.